Okay, so we're going to look at finding the composition functions f of g of x and g of f of x, and also determining whether or not these two functions are inverses of each other. So we begin by finding the composition f of g of x, which basically is saying we're going to put into the function f the function g, which is x plus 5 over 9. That's going to be our input to the function f. Now, whatever you put into f, you multiply it by 5 and you subtract 9. And we're putting x plus 5 over 9 into f. We're going to think of 5 as 5 over 1. We're going to think of 9 as 9 over 1. So in order for us to carry out this multiplication, we've got to multiply the numerator of 5 over 1 by the numerator of x plus 5 over 9. And we have to also multiply the denominators. So this gives us 5x plus 25 over 9. And from that we subtract 9 over 1. Now in order for us to subtract, the denominators have to be common. So this denominator of 1 can be multiplied by 9 in order for us to obtain this denominator of 9. We also have to multiply the numerator by 9. So we get 5x plus 25 over 9 minus 81 over 9. Since these denominators are common, that denominator is going to remain a 9. There's no change in the denominator once both terms have the same denominator. And I simply carry out the subtraction with the numerator. So 5x plus 25 is going to have the 81 subtracted from it. And this gives me 5x minus 56. That's over 9. And the important point about this result is that f of g of x is 5x minus 56 over 9. Since that's not x, f of x and g of x are not inverses. And we can simply say they're not inverses, or we could say they're not inverses of each other. Here's the important point, and that is that in order for f of x and g of x to be inverses of each other, f of g of x has to be x, and we also need g of f of x to be x. If either one of these results doesn't happen, the functions are not inverses of each other.